Chapter 3 review. We're going to look at problems 11 through 20. And so number 11 is looking at another proof. And so I want to make the left-hand side of the equal sign, left-hand side, equal the right-hand side. And so I'm just going to rework one of them and make it look like the other. So if I look at all my answers here, I'm just trying to prove which steps actually go with it. And so I can see that the left-hand side is the same throughout. So that means that I'm going to change the right-hand side. So I'm just going to work with the right-hand side. Left-hand side is going to stay the same. So I have a parenthesis and another set of parentheses. So that's multiplication. So I'm going to take this x and multiply it by all three of those. So x times a x squared, and then a x times an xy, and then an x times a y squared, and then I'm going to take y and times it by all three. So y times an x squared, a y times a xy, or a negative xy, and then a y times a y squared. And we can see that if we look at all these possibilities, we can see that step is right here, timesing each x by all three of them, and then timesing the y by all three of them. X times all three, y times all three. Now once I find that step, now I can see, okay, what do they do next? Well, they actually multiply it, right? They multiply these two, so we get an x cubed, we get a negative x squared y right here, and then we get an xy squared, and then we get a yx squared, and a negative xy squared, and then we get a plus y cubed. And we can see that answer just below it right there. Okay, and then we can rearrange these, right? So if I rearrange them, I notice that that one just kind of puts those together and factors out a negative. We haven't done that. And then this one, we notice that they have, so if we put all the negative x squared y together, we have an x cubed, and we have a negative x squared y, and then a positive x squared y, and then a positive xy squared, and then a negative xy squared, and then a plus y cubed. So we can see that that one has, this one has 4, like I was kind of saying, started to say. But I haven't combined any like terms yet, right? So here I notice that I put those together, I still have 6 terms, so I'm on to that one. Now if I combine those like terms, right, these get subtracted over, and these get subtracted from each other, I just get x cubed plus y cubed, which is just this one. So those are the 4 steps that get me the left-hand side equals the left-hand side. Okay, on the next one, using synthetic substitution. So this is our x value that's going to go into our box. And then these are my coefficients. I notice that I have a degree of 4, so I should have four coefficients, which is 1, 1, -2, 5, and -4. And so I'm not missing anything, so I'm good there. Put a 0 in the second row, add those together, multiply by what's in the box, add, multiply, add, multiply, add, multiply, add. I get 17 as my remainder. So f of -3, plugging in -3 into my equation, I get 17, my y value. And so that is my answer. So the remainder goes as the answer. What I'm putting into the box, that's what I'm taking f of, -3. Now this bottom one right here, I'm going to do synthetic division again. I have a degree of 3, and so I should have 4 terms, which I do. And so I have a 1, -8, 19, and a -12. Okay, and they tell me this time, they say x minus 1 is a factor. So up here they said f of -3, that means x equals -3, so -3 went in the box. But here I have x minus 1 as a factor, so what goes in the box is what I set equal to 0, so that means x equals 1, so 1 would go into the box. Multiply down, multiply, I get 1, subtract, I get -7, multiply, I get -7, I get 12, multiply, I get 12, and I should get 0. And I should get 0 as a remainder because it does say it's a factor. So that means I should get 0 at the end. If I didn't get 0, maybe I multiplied wrong or added wrong, or maybe I forgot to put the opposite in the box. So when they say a factor, I'm going to put the opposite in the box. Now what I can do to find the remaining factors is I can see that I have cab here because I have 3 remaining. So I can try to factor it, or I can continue on with synthetic division and try to guess and check what the other ones are. Okay, what the other zeros or roots are. Or I can cab it, so I have C times A is 1 times 12 is 12, and my B is -7. So I can ask myself what times what is 12, but adds to -7. That'd be -4 and a -3. Divide those by my A, which is 1. So then my factors is x minus 4, x minus 3. So those are my other 2 remaining factors. And so there they are. So x minus 1 is a factor, x minus 4 and x minus 3 are factors. So if it wasn't factorable, then I could leave this as a quadratic. X squared minus 7x plus 12 would be the other factor. So I have to be able to cab it or factor it. You could use quadratic formula and to solve, but remember when you're solving quadratic, it's x equals some number, right? So then to write factors, I would do the reverse, right? I would try to solve for 0. Okay. All right, with synthetic division again, here again it says f of 2, so 2 is actually going to go in the box, which is actually up here. I can put a 0 here, add those, I get 3, multiply, I get 6, add those, -2, multiply, I get -4, add those, I get 5, 5 times 2 is 10, add those, I get 4. And so I'm just looking for make sure you can do synthetic division. So the next one I'm also going to do synthetic division. Here's my polynomial, and I'm trying to figure out where x represents a year since 2010, and so we want to find which option below uses synthetic substitution to estimate the price gasoline in 2011. Well, what's the difference between 2010 and 2011 is 1 year, right? So my x is going to be 1 that I'm going to plug in, and my coefficients are 0.03, -0.4, 1.18, and 2.75. Zeros in the second row, add those together, 0.03. I have all 0.03s in all of them. 0.03, 0.03, 0.03, 0.03. Then I can multiply that, get 0.03. Those are all the same. Oh, this one's negative, so I know that one's not it. This one also is negative, so I know that one's not it. So we're down to just these 2 here. Okay, when we add that, we get -0.37, and we can see that if we check those answers, this is -0.43, so that's not it. So this one has to be it right there. Okay, and you could keep on doing it using a calculator to figure out what you get there, but the first one is it. So make sure you're careful with your negatives, what you plug in the box, multiply your negatives and adding, right? So just check your work. Here we're checking the number of positive solutions. So the number of positive solutions, I count the sign change, positive x to the 5th, and a -2x to the 4th, that's one sign change. A -2 to a 3, that's another sign change. From a positive to a negative is another sign change, and from a negative to a positive is a 4th sign change. So I have 4 sign changes, so that's positive real roots are 4, but I can also decrease that by 2. So 2 and then decrease that by another 2, I get to 0. Then to find the negative solutions, I times all my x's by -1. 2, -1 to the 4th, plus 3, -1 cubed, -4 times -1 squared, and then plus 1 are constant, right? So I can recheck these. That becomes just a negative. -4 cubed is a negative, but a negative times, oh sorry, that's a positive, and a positive times a negative still a negative. Negative cubed is a negative, but times a positive is a negative. Negative squared is a positive. Positive times a negative is a negative, and then we have our constant, so that's a plus 1, plus. So sign changes, count my sign changes, that would be none, 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 1. So we got 1 sign change for our negative, and I can't decrease that by 2, right? So it just stays at 1. So those are all my possibilities. Okay, looking at graphing this and which one of these represents it. Right, we notice that it faces down, so we can see that there's a -x squared there. some sort of quadratic, and it's a negative, so we know it's going to be a negative, which all those are negative, so we can't throw any out right now. But we see that we have x-intercepts at -3 and at 1. So if those are my x-intercepts, that means my factors are x plus 3 and x minus 1. Now I could FOIL this out. So I could FOIL this out, and I get x squared minus x plus 3x minus 3, combine like terms, x squared plus 2x minus 3. And then I notice that none of those answers are there, and we know we need a negative, right? So I notice that out in front of all this is a -3/4, -3/4. So maybe I just times this whole thing by -3/4, or I can times it by -1/3, because we can see that's in front of all of them. Okay, so I'm going to multiply, let's just do -3/4, top one. So I want to multiply everything in here by -3/4. So I get -3/4 x squared. I get -6/4 x, and a -9, or positive 9/4. We can see that these look similar, but this is a negative and this is a positive. I get a positive, so maybe this, but that's a -3/2, and I got -6/4. Well, can I reduce that -6/4 to -3/2? Right, reduce them both by 2. So there we have our answer. So if none of those works, then I would multiply everything by -1/3 and see if that represented. So this second one is the one that works. Okay, looking at 18, we're going to have and find out which ones are positive, imaginaries, or not roots at all. So looking at this, we could do synthetic division. We could make sure we have our 1, 0 for x cubed, 3 for x squared, a 0 for an x, and then our constant. Right, and I could run these answers through, especially the real ones, to see if any of these real numbers are actually roots or solutions. Right now I'd want a 0 at the end when I run through synthetic division. Or I can see that this is quadratic form, because if I double this exponent, I get this exponent. So I could rewrite this as x squared times 3 plus x squared, right, minus 4. So this is my A is 1, my B is 3, and my C is -4. And so I want to try to either use quadratic formula or factor it. But remember, when I do quadratic formula, it's normally x equals. But here, since my second term is x squared, it's going to be x squared equals. So I can try to factor it, which I believe it is factorable. I can use CAB. So that would be A times C is -4, and then our B is 3. So what times what is -4 but adds to 3? That'd be a +4 and a -1. I can divide by 1, which doesn't change anything. So I get x plus 4 is a factor, and an x minus 1. And that equals 0. But normally it's x, but this is x squared. So these are actually x squared plus 4 and x squared minus 1. Then I can just both set these equal to 0. X squared plus 4 equals 0, and x squared minus 1 equals 0. So we have x squared equals -4, and x squared equals 1. Square root both sides. Square root of negative is I, so I square root 4, which is plus or minus 2i. And this one, square root of 1, is just plus or minus 1. So these are my solutions. And I could use quadratic formula as well, but it would be x squared equals whatever my answer to quadratic formula is. And then I could square root both sides to get rid of the root, or to get rid of the squared. So my real roots, real numbers, are plus and minus 1. And then my imaginary are plus and minus 2i, and then whatever the rest are, 1 and -1 are solutions. So 2 and -2 are not solutions. Those didn't work out. All right, I didn't get them as answers. And then I and -i. I and -i. So those are not roots. Well, you can plug those into synthetic division until you get them all. And you could try I, but I wouldn't try the I's. I'll just try these ones, which ones work. And then once you get down to 3, keep on going until you get down to 3 coefficients, and then you could use quadratic formula to find the other 2. All right. So next one, we are going to use quadratic formula. So the next one we're going to use quadratic formula. Here we have a degree of 5, so that means we should have 6 terms. So that's a 1, -3, 3, -1. We don't have an x, so that's a 0, and we don't have a constant, so that's a 0. So here we can run through synthetic division. We have our choices -1, 0, 1. So we can try -1 first. We get -1, we get -4, we get 4, we get 7, we get, oh, come on, my pins, there we go. -7, we get -8. So that's not going to work. We're not going to get 0, right? Because that's 8, that's -8, that's -8. So -1's not going to work. Okay, so that's not a 0. Not a 0. Okay, so that didn't work. So how about trying 1? So let's go ahead and plug 1 in. Maybe 1 will work. And some of you guys might be quicker than others. You can figure out that 1 and 0 do work. So run 1 through. I get 1, I get -2, I get -2, I get 1, I get 1, I get 0, I get 0, I get 0, I get 0, I get 0. So 1 does work, but this multiplicity thing means 1 could work multiple times. So now I just drop a 0 off. So I just take this last 0 and drop it off. Use these coefficients as my new ones, and then run 1 through again. So 1, 1, -1, -1, 0, 0, 0, 0, 0. That means 1 worked twice. Now I can try it again. I have new coefficients. This is a 1. By the way, drop this last 0 off. Do another one. 1, -1, 0, 0. And try 1 again. I get 1, I get 1, I get 0, 0, 0, 0, 0, right? So 1 worked a third time. Now I notice when I drop a 0 off this time, I get 1, -1, or sorry, 1, 0, 0. So here if I try 1 this time, try 1, I get 1, I get 1, I get 1, I get 1, so it didn't work, right? So that's all the ones that work. So just 1, 1, 2 1s, and 3 1s. So that means 1 worked with a multiplicity 0 of multiplicity of 3. Okay, now I can try 0 because it's my last one, right? So I can continue right here. I can just plug a 0 here. 1 times 0 is 0, 0, 0, 0. So it did work. I got a 0 at the end. And now I can drop off that 0 and I get 1, 0. 0 down here. And now I can try 0 again. I get 1 times 0, 0, 0. I get 0. So 0 worked again. And now I drop that off. All I have is 1, so I can't do it again because all I have is left is 1. So 0 works with the multiplicity of 2. So 0 multiplicity of 2. Okay, the last problem I need to fix real quick because I forgot the last graph. Okay, with this last one, added that one on. Okay, so we will have a template of a shipping box, cut a square from each length. So basically we have a square and we're cutting a certain length, x out, and cutting x out, and 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 an x out. Right, so as this original one was 14, when we subtract an x and subtract an x, that becomes 14 minus x. So it kind of looks like it just goes from there to there. And then here, this originally was 12, but we're cutting an x out, so minus x, that'd be a 12. That'd be a 12 minus x. So it probably looks, the diagram probably looks, oops, something like this. Something like that. So that's 14 minus x, and this would be 12 minus 2x. Oh, that'd be 2x too. Right. Okay, and so then we can find the area of this, right? These are folded up and it just turns into, I'll try to draw it, basically something like that, I guess. I don't know. Something like that, right? So, and then we can find that the volume of this, I think that's what it after volume, okay? So volume would be multiplying those together. Okay, so multiplying those together, but then our height is x, and maybe that's what I left out there. So this is going to be a cubic, right? Because we have x times x times x, so it's actually a cubic, so we can kind of get rid of that one, and that's why. So then we can think about this too. One way to think about it is we can FOIL all these together and put it right as a polynomial. F of x equals a polynomial, and then we could just go ahead and graph it, right? So that's what we have to do. And we know that we're trying to get our x-intercepts. So there we can think about setting this equal to 0, and if we solve for x, we can add 2x to both sides, divide by 2, we get x equals 7. Here, we get x equals 6, and here we just get x equals 0. So we can see we have x-intercepts 0, 6, and 7, 0, 6, and 7, 0, 6, and 7. This one's just 6 and 7, so we can eliminate this one. And so there we're have a tough decision between these two. We have the x-intercepts, but which do we want our graph to face? Do we want it to face, coming down? Because remember, this x represents, do we want negative volume, or do we want positive volume, right? So we probably want positive, so it's most likely going to be this one. But we could FOIL this out. So I'll pause the video and FOIL it out for us, see what we get. Okay, so if I FOIL out 14 minus 2x and a 12 minus 2x, I get this 168 minus 28x and minus 24x, which is a negative 52x plus 4x squared. But then I got my height, which I forgot about earlier because we're doing volume, so I multiply that in and I get 168x minus 52x squared plus 4x cubed. And then I can plug that into a function, and I can see that I actually get this one right there. Okay, so that's it for problems 11 through 20.